Okay, so for the regressions pattern unit, I chose to look at this fractal question. It was released by the Alberta government in 2009 as a set of prep questions for students going into diploma exams. And the reason I chose it is because it has some of the standard elements that you're going to see for one of these, and on the other hand, it's a trick problem. It's kind of strange. They give you this excerpt there talking about how the iteration grows with the triangles there, and you can see it in the picture that the number of unit triangles is growing. If you count them up, you'll notice there's 1 in the first picture, there's 4 little triangles in the second picture, 9 triangles in the third picture, 16 triangles in the fourth picture. And I mean, they labeled the first picture as iteration 0 because it hadn't changed yet, right? We remember with iterations, we start with iteration as 0 as the original, and then 1 is after one change or transitions happen. So your course of business on this, you have to decide whether or not this is an arithmetic or a geometric sequence, okay? So in this case, here, if you look at this, it goes up by 3, and then it goes up by 5, and then here it goes up by 7. So it's definitely not arithmetic, right? So that leaves us with geometric from what we talked about. So this is a geometric sequence. The strange part is, we also said that if it's geometric, you should be multiplying each term to get the next one, right? If you go 4 divided by 1, it's times 4. So it's obviously the plus thing doesn't work. We said for geometric, you should be multiplying by some number to go through the terms. Here it's times 4, right? You multiply 1 by 4 to get 4. Here, to see what it was, you can go 9 over 4. Well, it's 2.25. That we have not seen anywhere else. It's rare. Here, 16 over 9, it's changing again. Here it was times 1.777. So the thing here that's strange is, yeah, it's roughly a geometric pattern, but what 99% of the time happened in class is if we had a geometric pattern, we used exponential reg. What I'm telling people, just because of really this single problem, is test it out using your diagnostic. Because in this case, if you throw these values into your list and you do diagnostic on and you try the regressions, you'll notice that actually quadratic regression is actually the best match, and that is the one that'll give you the correct answer. So that is extremely rare, but what I tell people is just check, because it could be this one problem that's actually a quadratic regression. So it's a quadratic regression. If you go through on your calculator, put these in your lists, and you do your regression, you'll actually get a 100% match for quadratic. So this is a perfect quadratic pattern. And for your equation, you'll get y equals 1x squared plus 2x plus 1. So that's your equation. Now from there, we need to figure out which one of these, going down 4, 5, 6, etc., which one of these would have 441 triangles in it. Now the easiest way to do this is obviously graph it. We need to find out for what x, which should be the iteration number, do we get 441 on the other side for y. What you want to do is, in y1 on your calculator, you want to graph this thing. And then in y2, you want to graph 441. Where the two meet, your intersection point, whatever x value it is where the two meet, that's going to be your answer. So from here, you want to go trace intersect on your calculator. So you go second trace and you go to intersect. Okay? So put those two into your calculator, hit intersect. When you do, and you're going to have to adjust your window a bit because 441, right, is really high in the vertical. So if you get an error, which you probably have if you didn't change that, change your window so that this big number fits on your screen. Go second trace intersect, and the place where the two touch is when x equals 20 in here. So you plug 20 into here, you get 441. So the answer here is 20. So when x equals 20, we have 441 unit triangles. So, as a quick summary, To start, figure out if it's geometric or arithmetic. After that, double check using your diagnostic which one's the best match, just in case it is this rare problem where it's quadratic. Usually it's exponential for geometric. After that, use your equation. Use the equation the calculator gives you to answer whatever problem you're dealing with.